So welcome. I've been talking for a while about the fact that I'm going to give you some ways that you might potentially be able to integrate a product. And this is going to be one of them, which is sometimes how a product came about was really from the chain rule. And then you can undo that using substitution. So I want to kind of introduce this in this lecture, and then we'll do an example in the other lecture, but I'll at least help you identify it a little bit in this lecture. Okay? So one of our goals is to figure out the product rule, right? And we reviewed the product rule. Okay, and I'm going to do this in terms of prime notation here. You should understand things both in terms of prime notation and like the DDX type notation. So 5 times G prime, this is a multiplication, not a composition, equals, so we do this by F G prime plus G F prime. So that's the product rule. And then there's another rule that involves kind of where products show up, which is the chain rule. So we have, in this one, we're dealing with a composition. So this is a composition, make it really obvious that that's a circle there. Prime, so this gives me F prime composed with G times G prime. So what do these tell us about integrals? Right, so this is kind of this goal in what we'll be doing. Okay, well, let's think this through for a moment. We're just going to focus in on the chain rule in this particular lecture. So let me just this is going to be our focus. Just in this lecture, and then we'll hit the other one. Okay. So the chain rule, and I'm going to kind of color code here a little bit. So the chain rule so if I'm going to take F composed with G prime, so I'm going to make this kind of big actually. Let's do this in kind of a suggestive way. So I'm going to go boom, boom, boom. So I'm going to do F composed with G prime. Okay, that's going to be blue, and then I'm going to have that this is going to equal, and then here I'm going to make this red on the other side so that you can kind of see what's going on there. I'm going to make the entire thing red, just trying to make this as suggestive as possible and easy to follow. So now the whole thing is going to be red. Oh, I also need my composition. This is going to be in here as blue. So, okay, I'm going to want the entire inside. In fact, I'm so much set on this looking exactly. It's good to help. I use color a lot to kind of create correspondences in your mind. Worse when you throw your markers on the floor, but this is kind of how life goes sometimes. Okay. When you're me. Okay. And then on the left-hand side, the right-hand side, I want to have F prime composed with G times G prime. Okay. And then, so what this tells us is this says, what does this say? This says that the antiderivative of, and then we do this whole thing in red, so this thing here, so F prime composed with G prime is exactly, and now we want the inside here, so big F composed with G. Okay, which you should recognize from over there. Okay, Well, then that is going to tell me that, so we're going to get, thinking through how all these things work, this is pulling a lot of stuff together, so this is kind of nice. So I'm going to get that the integral of this critter dx is actually going to equal, and then I'm going to get that plus c. So I'm going to get f, right? How does this look? This looks like f of g of x plus c. Okay. We've composed the functions. That's all I did there. So in other words, so here's our substitution rule. If I want to take the integral of f of, and I haven't used orange yet, so let's use that. And I'm going to add a color in here. No, I'm not going to yet. I'm still going to write this as f of u times du dx I'm going to get the integral of f of u du. I'm just going to write it like this over here. Okay, so let's kind of think about what's going on for a moment. Okay, so how do we identify this kind of situation? And then we'll do examples where we actually work through it. So how to identify? This is kind of important with a lot of these. So I have a function on the inside, right? So that's kind of like an inside function. And I like to say with the derivative next door. With, and then this one here, we haven't used blue in this picture, so I can kind of almost, I'm going to box this. This is like the derivative next door, okay? With the derivative next door. Okay, so let's say there's a little bit of room over here. So maybe on this one, I'll just kind of give you some examples of the kinds of integrals that you might use. Okay, where I've got to kind of use the, you're going to see the orange and the blue there in these. So examples where substitution applies. You should see a lot more. Okay, so if I want to have the integral of, and then I just go, oh, well, what if I take, so here's kind of almost a hidden way that this can look. So I've got, or, so let's put on the bottom, so I have a function on the inside. So you could say, okay, well, I'm going to put this in parentheses so you can see. So my function on the inside could be x squared minus pi. Okay, so what would I see on the top there? So the derivative next door, well, this can actually kind of end up being up here. So this is the derivative of that function, dx. Okay, so that's one example. Here's maybe another one. So I could take, the integral of, and then I'm going to have my outside function, so maybe I'm going to have cosine of, and then maybe my inside function is going to be, oh, don't want to just use a polynomial. Let's do e to the 3x, okay? And then my derivative next door would look like, so I would have to have 3e to the 3x, and then the dx. So this is example 1, this is example 2. I feel like I can squeeze another example in here, so let's do an example 3, very carefully. So what if I want to take the integral of, and then I have e to the maybe I could have x squared in there even. Let's just do something very basic like that. Again, and then I would have a 2x maybe next to that, and then dx. Okay, so you really, in each of these, you should look for, you don't just need to have an inside function, you need to see that derivative. And next door could mean on top. This is really like having a 1 and then a 2x dx over there. Sometimes you're going to be missing these constants, and we'll deal with a few examples so that you can see. Sometimes you might be missing your constants, and then you can basically add them in. So we'll kind of deal with that. But right, so I have this function on the inside. I see its derivative next door. Function on the inside, its derivative next door. Okay, so that's what substitution is going to look like, and then we'll go through some examples for you. And it's the undoing of chain rule. Okay. So again, what we did in here, we're basically undoing the chain rule and noticing that if we had done the chain rule when we work back the other direction, you're going to see this you're going to see this function with like an inside function and then the derivative of that next door. And then you're going to actually figure out how you actually go through and compute this in practical examples, and we'll go through step by step. Also in terms of identifying, we'll do a lot of examples of identifying it and manipulating it a little bit. Okay, so I hope this made some sense, and I will see you in the next lecture.